Good morning, friends. This lecture is on the advances of sewage treatment, especially. We are also looking at a little bit on the sludge digestion, which will be made clear from the case study which follows. And as a beginning, we are going to have a look at the rotating biological contactors. Rotating biological contactors are also it's also an aerobic treatment process. We will have a look at this case study of what is done by Planetech. Planetech makes these RBCs, and here is their chief giving a talk about one of the installations of his RBC.
Hi, my name is Necdet. I'm the founder of Planetech Wastewater Treatment Company. And today we are in one of the housing complexes that we finished the wastewater treatment. And what you see around is a beautiful playground, a swimming pool, and here is a pirate ship, actually. And I would like to give you some information about the wastewater treatment, the Planet Disc unit of this housing complex. Now, the most important thing about this place is there are children, there are people, and the wastewater treatment plant is right nearby all this natural area. Now, we'll go to that place, our Planet Disc area, and I would like to tell you more about it. Please follow me. Right now we are in the plant, and what you see is the Planet Disc RBC unit, Rotating Biological Contactor unit. Now the wastewater enters in the RBC unit after it goes through a coarse screen, a fine screen, and then a grease and grit trap. And after that, you'll see it in detail. It does go into a sedimentation tank, and then a buffer tank, and then it goes into the RBC tank, which is the reactor. Now, it is important, I'm not going to get too scientific, but it is important that the wastewater does go through a sedimentation tank, because what we need is the soluble BOD. Not everything, but the soluble BOD. Now, after it enters, what you see is a pack of discs. There are 100 discs there, and it's rotating at approximately 3 RPM. And the bacteria sticks to the surface of those discs, which are HDPP, high density polypropylene disc, which is it's got about 50 years lifetime, and it does need the oxygen. Now, in a classical system, a typical wastewater treatment unit, which is about 250 to 350 people, depending on what you want in and out, you need approximately 4 to 5.5 kilowatts of blower, power of blower. Here, what you see is, please follow me, this small electrical motor. That small electrical motor is only 0.37 kilowatts. Now that's a hell of a lot of savings when you compare to the classical system. It receives the oxygen directly from the air because the water is right here, below this part, and the rest of it is exposed to oxygen. So it receives the oxygen directly from air, which is free. You don't have to spend a lot of electricity. Now, approximately, I will give this information to per person per month. It is less than 10 cents electrical power that you need for this unit. 10 cents US dollar per month per person. Now, after that, it goes through a sedimentation, which is a final sedimentation tank, what we call a lamella clarifier. It is upside down pyramid. It's the sludge, all those particles which is coming from the dead bacteria, let's name them dead bacteria, it's sedimented and it's collected at the bottom of the lamella separator, and we do have a sludge tank, and the sludge tank works for about a minute every hour, and it takes the sludge from the lamella separator to the sedimentation tank. And what you get is beautiful, clear water. I would like to show you a sample of that water, and bear with me and come with me, and I'll show you what we get from the lamella separator. Okay, now we'll take the sample together. Okay, this is the initial part. We may have some TSS, pouring it. Okay, now we're filling it again. Now we'll see the end result directly from the lamella clarifier without the sand filter or the carbon filter or anything. This is the end result directly from the RBC, directly from the planet, which is beautiful. Now, I want to smell it as well. What's it? There's absolutely no smell. I wish you could be here and smell it yourself. Okay, now what you see here is a clear bottle of water after the lamella clarifier, planet disk, lamella clarifier, and here's the water. Now this is 95% free of bacteria, but there's still 5% bacteria, and if you want to get rid of it, what you do is you take it through a sand filter and a carbon filter, active carbon filter, it's a multimedia filter, and then you take it through 2 stages of disinfection, which is one, chlorine, and the second one is the UV. We like to go double bag and make sure that it is all disinfected, and then you can use it for irrigation, car wash, for cooling towel water, for toilet flushing, anything you want safely. In the 21st century, one of the biggest problems is the depleting water sources. At Planet Tech, for the last 11 years, we have been protecting the water sources, and we have been reusing the water we are treating with the help of Planet Disk. Now, Planet Disk is a sustainable solution because it hardly uses any energy, it's got no smell, no noise, and we are very happy and very proud to be at your service. We have been exporting our products, and please call us if we can be at your service as well. Thank you very much.
Anaerobic digesters come in many forms, shapes, and sizes. They're designed to take different types of unwanted organic matter, things like food waste, sewage, or animal manure, and turn them into a source of renewable energy.
Outside of corn-based ethanol and a little bit of biodiesel, in terms of what we call second-generation renewable energy or bioenergy technologies, anaerobic digesters are really the ones that are happening.
In this region, digesters are found mainly on dairy farms. Methane from dairy manure is a significant source of greenhouse gas emissions from agriculture.
Anaerobic digester really helps take care of that. In addition to that, it produces renewable energy, and it produces a number of different products that are nutrient-related products.
The operation and maintenance of an anaerobic digester hinges on material transfer, both into and out of the system.
This particular digester for Vanderhoek Dairy is a GHD design, which is a modified plug flow mixed digester. It is sized for 45,000 gallons a day of influent. That influent consists of dairy manure and a small portion of outside substrates.
At the Vanderhoek digester, manure from the main dairy is pumped nearly 2 miles through an underground pipeline to a 30,000 gallon holding tank beneath the barn lot. Off-farm organics and manure from other dairies are delivered by truck to a second pit. All the influent is stirred and mixed together, supplying a consistent flow of liquid, which is piped into the digester.
The very simple explanation of a digester is it's just a tank that is almost like an extension of an animal's stomach. So it just keeps up the digestion process for an additional length of time, and most of the dairy systems are 20 to 25 days.
As the material travels through the digester, it is heated and kept at a constant 100 degrees, the body temperature of a cow. The temperature, along with regular agitating and mixing, continues to break down the manure, releasing methane gas. This biogas is collected, cooled, pressurized, and used to power a large generator. The electricity produced is then sold to the local utility. The energy needed to keep the process going is reclaimed from the system itself. Temperature and flow are maintained using excess heat from the engine and generator set. A portion of the captured gas is sent back to aid in the mixing of the digester liquid.
There's no mechanical agitation inside the digester. We take a portion of the biogas produced and we recirculate that into the digester. And that keeps a rolling motion. It's constant in, constant out. So at 22 days, that manure's coming out. It goes through a separation process.
The effluent that flows out of the digester is now significantly reduced in pathogens and has little or no odor. It is pumped to a separator where the liquid is removed and the remaining solids can be sold as an organic fertilizer or used by the dairy as bedding for their animals. The liquid is stored in a lagoon where it is used to water and fertilize the farmers' fields.
Anaerobic digesters are being built, there's an industry growing, and that industry needs technical expertise in order to move on.
BTC graduate Todd Andrew is an anaerobic digester technician in Whatcom County. Todd will take us on a walkthrough of the Vanderhoek digester to give an idea of what the job is about.
This is where all the substrates or manure gets pumped into this octagon pit. Anything that comes off farm or from another farm will get dumped into here. From here, all the manure and influent will get pumped with this pump and agitator. This is the only mechanical part on this pit. We just check and make sure all the, belts are fine, the pump is working normal, it's pumping what it should, and that the timers are all set so it pumps at the right intervals. The biggest thing is just making sure that the probe that turns the pump on and off is clean and doesn't have anything sticking to it, because then it can run the pump dry. From this pit, it's pumped over to this barn lot pit, which is another 30,000 gallon pit that's underneath the cows. The manure that comes to this pit is being pumped from about a mile and a half away from their main dairy. The reason they do that is we can have more of a community digester because they can pump it from different farms in to feed the digester. And from there, that's where it'll get pumped to the digester on a timer also. So that's where the digester gets everything fed to it, is from this pump in the barn lot. So this that we're coming to is the digester itself. It's basically a concrete storage tank. It's a U-shaped concrete storage tank. So the manure comes in there, it can run down that side and come back on this side, and that's where the heating and the mixing is done to keep the manure flowing to the effluent pit and on its way out. When we come up here, we'll basically do a walk around just to check structural integrity and just make sure the tank itself, everything is normal. We'll check our pressures on the tank pressure. We'll pull the temperature probes out and we'll probe down through those, check the kind of the thickness or thinness of the manure that's in there. Since you can't see it, we have to do it with a probe stick so we can feel what's going on inside. If it's too thick and I have too many solids, then I'll up the agitation for that zone just to keep it moving and to keep it so the solids can't settle out and get too thick. So after it makes its U shape here, this is where the manure comes out, or comes to this area. And this is our gas collection box, where all the gas from the digester comes through this box into the pipeline. From here we have a flame arrestor. The flame arrestor looks like a honeycomb inside, and it traps, basically makes it so it can't burn back through it. We'll pull it out every 600 hours or every oil change of the engine, or on a bi-weekly schedule. We'll pull it out and clean it with just hot water or a pressure washer. We try and drain the moisture out of the pipeline just from here, where we get some of the moisture out before it heads to the cooling. And then this would be up above here would be the flare relief, where it goes through a one-way valve that has weights on it. So once it gets to a certain pressure, it will relieve the excess gas, and then we burn it. It's on a sparker so that it will ignite the extra gas, and we'll flare it if it's not needed, or if we have more than we can use. After we get all the gas, we have to get the liquid out of this tank. From this effluent pit with this pump, it'll get pumped to the separator, where we separate the solids and the liquid. Kind of basic for all the pumps and agitators is just on a weekly basis, grease them and check operation. Okay, so from the digester, where it comes from the effluent pit, it's piped over to the separator here. So this is where the liquids and the solids are separated. Basically, it's got a screen behind there. This is pumped over, and it's on a frequency drive on the motor, so we can up the flow or slow it down. So we just check those to make sure that it's feeding the separator properly. The liquid will fall through the screen, or the solids will continue to slide down to the auger. It'll squeeze the water out, and the water can run down below, and the liquid will run out to the lagoon, and then the solids will be used for bedding or fertilizer or gardens. And the big thing with keeping this maintained is just so you get the most solids out of the liquid before it goes to the lagoon. You know, we got to keep the auger clean, and we have to check bearings, grease bearings, check the gearboxes. Once weekly we'll hose it down, do a whole pressure wash on it, just to keep it as clean as possible so we can separate as much as possible. And this is where the solids off of the separator come down to after they're separated from the liquid. This is the material that they'll use for either bedding for their dairy, fertilizer. You can use it to grow grass, gardens. It's basically a marketable product that they can either sell or use themselves. One of the other nice thing to have is be able to familiar with farm equipment or loaders, because you have to move the pile so often. It's just got to be moved or loaded into trucks. So that's a key thing to have as a loader license, or be familiar with farm equipment or training. So this is where the gas from the digester is piped into the building. You can see more of that inside. But since we're out here, I'll show you, this is the dump radiator that we use for getting rid of any excess heat that we don't need for the digester. We check the fan blades on that, clean it, make sure there's no leaks, visual leaks. From there, we have the water storage tank. That's where we store the water that the engine heats, so we can mix to heat the digester. The gas runs inside the building, but then it also runs back out here, and through this plate exchanger is where we're cooling the gas. Once we cool it, we'll drop out the moisture, because you don't want moisture in the gas going to the engine. You want it as dry as possible. So that drops out all our moisture, and then it goes back in, and that's where it will get fed to the engine and boosted in pressure and fed to the engine. So with the plate exchanger, there's not a lot of maintenance, just making sure that the chiller is running. We'll check the refrigerant charge and the pumps that are running, and make sure that the fans run, and then we'll do that on a weekly basis, do a walkthrough on it, check the controls. As we were saying before, the gas line comes in, you can see it comes through the ceiling. We can kind of follow it. It goes out to that gas chiller and through that plate exchanger, where we're dropping out as much moisture as possible. As it comes back in, we'll use some of the gas for the roots blower for our agitation in the digester. And through the roots blower, what we'll check on a daily basis is the oil level, make sure there's no oil leaks. make sure that it's operating, that the bushings and bearings are good. From there, the gas is boosted in pressure for our agitation, which goes through the 5 zones, and we'll make a visual check of that. There's no lubrication or parts on any of that. It's just a matter of making sure that they open and close. The gas for the engine goes through 2 gas boosters, which boosts the pressure to above 30 inches of water column, so we have adequate gas pressure for running the engines. All the gas that goes to the engine is metered, so we can see how many cubic feet per minute they're using. So the gas is used to agitate the digester, agitate the zones, and the water is used to heat the zones. So the water line from the storage tank that we showed outside, this is the main water line off the bottom, and it circulates water through this header and back to the top of the tank to keep the hot water circulating. As it does that, these are the 3 zones for heat in the digester. So when these are calling for heat, the pump will turn on. It'll pull water off of this main header that'll be a constant temperature of the tank. This style has a greasable motor on it. Some styles, like these smaller ones back here, they don't. They're non-greasable, so they're pretty, not a lot to worry about, or not a lot of maintenance on these besides making sure that they're not leaking water out of a mechanical seal. All the water zone temperatures and the gas recirc timers are all controlled by the digester control panel. A typical scenario that I check on a daily basis is check all the temperatures and make sure that they're all within where they should be. Between 98 and 100 degrees is where we want to keep it at all times. And these would be your 5 zones of agitation here, and we can control those through this little PLC. We can adjust the times of how long each zone is and how long it carries over from one to the other. This is a little bit older system. The newer systems will have more of just a touch screen that you can actually turn the pumps on and off from this touch screen instead of having so many switches. There's a lot more they can do via computer. They can program it off of site with the new system, so they don't even have to be there, and they can change a program for you. You can just call them. Okay, so the gas comes in from the digester after we've cooled it. Comes in, after it runs through the turbos, through the aftercooler, we cool it again because the turbos make heat. It'll come through the intakes, fire the engine, which then as the engine's running, once once the breaker locks in, it will run the generator, start producing power to the grid, and then we get rid of the heat through the heat recovery, which goes to the water tank to heat our digester zones. We'll do an oil change every 300 to 600 hours, depending on how all the oil samples look. We also adjust all the valves, the intake and exhaust valves on the engine every 1,000 hours. On a daily basis, I could kind of, we'll check all the gauges, make sure our water temperature and our oil pressure is within specs. With the computer system, it helps you a lot because you can set parameters of, it'll send you an alarm if the water temperature is too low or too high, or the oil pressure is too low or too high. There's just numerous things that you can do with the COMAP system compared to older systems where it was all manually done. With new technology, it keeps getting better and better, so it's easier to tell where your problem is before it's a major problem. I can sit at home from my laptop and I can start and stop the engine. I can monitor all the cylinder temps. I can see everything that's here from my computer sitting at home. So then this is where they keep the switch gear for the breaker, which sends it out to the PSC, to the grid. It's all computerized and all done electronically. The only thing that might have to be checked is there's a couple fuse blocks in there. If you did have an issue, you might have to check fuses. But other than that, I never have to change anything in here. And every site kind of has their own layout as far as, what they want checked. And we'll come in and we'll get their checklist for their certain site. You just go through and do a checklist and write it all down, so we have daily documentation. Like I say, we'll do oil temperature, the amount of hours on the engine. We'll go through and just record the digester temperatures, oil added to the engine if any needed, the roots blower or the gas recirc oil levels, digester pressure, and then check all the pits and the washdown, make sure the separator is working and the effluent pit and pump is working. So if we see a problem come up in the future, we can look back and say what happened 22 days ago or 28 days ago to know what went in the digester and what came out, how many gallons went in, and we can tell a lot from those different parameters.
As anaerobic digesters continue to be planned and constructed around the country, there is a growing need for qualified technicians.
They need to be able to know how to operate and maintain and perform routine maintenance and upkeep on these anaerobic digesters and all the peripheral equipment that goes with them.
Specific duties will vary by facility, but overall, the technician's job is to maintain the workflow common to all digesters. Material handling, both into and out of the digester. Maintaining temperature, mixing, and flow within the digester. Solid separation and secondary treatment of effluent, and repair and maintenance of the engine, generator set, pumps, valves, and other mechanical equipment. The importance of developing renewable energy sources like anaerobic digester technology is only going to increase in coming years. Upon successful completion of this program, graduates will be prepared and qualified for entry-level positions in this growing career field.
This was a very interesting presentation, a case study on how anaerobic digesters work. And of course, as they had given the disclaimer, these need not be the only technologies which are available, and this may not be actually representing the state of art of digesters. However, the fact still remains that it is going to be the future, and in a country like India where we have a lot of cattle, we can definitely optimize and make the biogas process viable. The number of heads of cattle which is there in India doesn't amount to the numbers which we saw here. And even the digester which was documented here is a community digester. And what we look at is in terms of the number of heads, each small farmer in India at the most has 4 or 5 heads of cattle, and they take it for grazing outside. So this actually causes that all the manure from the heads of cattle are getting lost. There is a very good chance wherein we will be able to emulate this system where where the community gets together, ensures that all the manure gets collected and it's taken to transported to a centralized space, and a much more meaningful way of generating power is done. So I wish you would think about this, and we do have an assignment on this. We will be discussing this video and another video which will be following this one in our next class. So do go through this case study and try to learn. So here are the references. These are for the 2 videos which you just saw, and thank you for watching.